Today I am here to introduce you to an amazing young boy. He is in 3rd grade and he is here to present to us a slideshow on quantum computers. Introducing Roland Raftery.
I stubbed my toe. Hi. Now, today I will be doing a slideshow on quantum computers. Let's begin. Quantum Computers by Roland Raftery. What is quantum computer? Quantum computer is a fast but accurate computer running on a thing called qubits. Qubits are a method of a bit in superposition. If you don't know what a bit is the part used into a regular computer to store data and such. But if you put a superposition on a bit, then it can be in a dual state no matter what. And meaning many more data can be held. Quantum computer is the fastest growing subject in quantum physics. I don't know. But for example, I'm going to compare the quantum computer to a supercomputer. So just a normal benchmark test. It would take a quantum computer like 200 seconds. Supercomputer, supposedly 10,000 years at the rate it was going. And so that means it's almost trillions of times faster than supercomputer, just known from this test. Quantum computer uses algebra for computations. Now by this I mean to find like basic addition, it uses algebra. To find like multiplication, it uses algebra. But it could do basic addition and stuff like that, but it doesn't, because algebra is easiest for a quantum computer. What do quantum computers run on?
Do they run on electricity?
No.
Ones and zeros. Is it ones and zeros?
Yes.
Teacher, is it ones and zeros?
Regular computers consist of ones and zeros. Quantum computers consist of ones and zeros, but quantum computer versus supercomputer. Now, quantum versus supercomputer. In this picture, it's just 1 qubit of a quantum computer. Now, this 1 qubit can store infinite amount of data. So, I bet this one supercomputer right here, every one of these boxes can store at least 10,000 bits inside, which is almost a square mile of that. That's probably one of the best computers on Earth. But one less than a millimeter sized qubit is trillions of times better and more accurate than that. Coin toss experiment. Supercomputer versus human. So it's just a normal coin flip. You flip a coin, if it's heads, if the human picks heads, then it's a positively charged particle, the human wins. Then you flip the coin again. It's tails, negatively charged particle, the computer wins. So normal 50% chance, supercomputer 50%, human 50%. Now, quantum computer versus supercomputer. So quantum computer uses the qubit method I told you about earlier. It has a superposition that makes it ones and zeros at the same time. So that means it's basically like cheating and picking both of them rather than just picking one. And so that means it's pretty much impossible for you to win against the quantum computer. IBM, IBM created a 1-qubit quantum computer in collaboration with MIT, Princeton, and Caltech. This computer was normal, and they put it to use to research more about quantum computers. IBM now in 2021. In 2020, September 13th, the IBM released a 65-qubit computer, holding the largest qubit world record for now. And other players in the game. Locally, other players would be Amazon, Microsoft, Google, those. But in all of the United States, there's barely any countries. America has the most. Germany and China are the only ones comparable to the USA. Quantum at home. Does anyone think that quantum computers at home are possible?
I think they're possible.
I think they're possible, but
Sorry. Quantum computers won't be at home because of the very little changes you would get. So normal computers these days are super high tech, running at 60, 70 FPS. That's almost as good as your eyesight can notice. So if you have a quantum computer, it would be so good your eyesight wouldn't even notice a difference. So there would be no point in wasting so much valuable materials such as copper and zinc on the smallest difference. The only difference it would make if you had a 16 FPS phone like mine. The cooling system. As you see in this picture, the cooling system is giant. Only right there is where the quantum computer is. All of these little tubes that you see are holding in liquid nitrogen, one of the coolest substances on Earth.
How big is that if you were standing next to it?
I would probably be about right here.
Okay, so it's big.
Because maybe it's on the table, I don't know. And see, there's even more going up from there.
Okay.
And so, these liquid hydrogens bring in to cool down the quantum computer. As you probably would have guessed, the quantum computer makes so much energy that it needs liquid hydrogen to cool. And it runs on 0.1 Kelvin, 0.1 degrees above absolute zero, where oxygen turns into liquid, hydrogen freezes, and how am quantum internet possible? This is just my theory, but this is how it goes. A qubit here, a qubit there, a qubit everywhere. By this I mean a hybrid model of quantum computer and supercomputer, only using a bit of qubits every little where in the internet to just help this supercomputer. That would make it still quantum, but very fast. Why do companies want quantum computers? What do you think?
For better data and better answers.
Maybe.
Secret.
They want it for security. Security is the basically quantum code. Now, a quantum computer has a self data lock. Basically, something where it stores data that only you can access. And so there's a basic encryption code for you. And using the qubit method, if you would try to hack into it, it would just change using qubits because it's ones and zeros at the same time. And so it's virtually impossible to do this unless you break the laws of quantum physics. Now, quality. As I talked about earlier, if you have a 16 FPS phone like mine, it would make the quality so much better on the apps and websites that runs on the quantum computer. Speed. Speed is just the same thing as quality almost. They want faster speeds on their websites for better. And entanglement. Now, I know you're wondering what entanglement is, but I'm going to go deep in it here. Entanglement is basically the twin of photons. Let's say you had a twin, but you were a photon. So if you spun up your photon, your twin would spin down. And so if your twin got data, you would also get data. So that means it's possible to teleport data and photons using quantum entanglement. Evolution. By evolution, I mean to revolutionize stuff like medicine, so quantum computers can study different proteins to revolutionize medicine. Our quantum future is here now.
Yay, Roland!